Hey guys, welcome to yet another interesting session by Intellipaat. We'll start off by understanding what exactly is data science, and then we'll go through some data science use cases. Following which, we'll look at different languages used for data science, and finally, we'll implement data science concepts using our language. So what in the world is data science? Have you ever come across huge amounts of data only to discard it because you thought it wasn't useful to you? Well, my friend, you couldn't be more wrong. Data is always useful to you. We just need to dig through it to find meaningful insights. So, data science is using some tools and techniques which help you to manipulate or wrangle the data so that you can find something new and meaningful. Now, what if I gave you a really long spreadsheet containing all the sales figures for the past 3 years? It would be difficult for you to comprehend the data, wouldn't it? So, instead of the spreadsheet, what if I gave you some charts and graphs related to annual sales? You would obviously prefer the graphs over the spreadsheet, right? This again is data science, my friend. Visualizing the data helps you get a better perspective and understand it easily. Now, every industry has its own problems, and the top management needs to take responsible and right decisions to stay ahead in the race. So, how does one get good at decision making? Well, that's simple. By going through the historical data and understanding what worked and what did not. And this is where data science comes in. Data science brings along with it a bag of techniques which makes decision making simple. Well, we are always curious about a future, aren't we? Now, what if I told you we can predict what happens in the future by analyzing the current data? Sounds like magic, doesn't it? Well, I'm no magician, but I can definitely use data science concepts to perform predictive analysis. So in simple terms, data science is a set of tools and techniques with which we can make the data talk to us. Now, let's go ahead and look at some data science use cases. In the telecom industry, customer attrition is a major concern. Every day, a new player comes into the market with new and attractive prices. In such a scenario, how does a company retain its users? So this is where data science plays a pivotal role. So the data scientists or the data analysts go through the data to understand customer behavior. They do a thorough analysis of data usage patterns, social media activity, and voice call or SMS patterns. The data scientists also analyze customer demographics so that proper segregation can be done in terms of age, gender, or geographic location. All of this analysis helps in providing the right offers to the right customers, and this in turn helps to retain the customers. Now, let's say you're at your home, happily eating a pizza, and you suddenly get a message on your phone stating that $10,000 was spent on your credit card to buy a diamond necklace, and asking you to verify if the transaction was actually done by you. You're shocked, and you immediately call up your bank and tell them that this transaction wasn't done by you and hold of the purchase. Now, how did the bank know that it was a fraudulent transaction? Well, data science again, folks. The bank keeps a check on your purchase pattern, and whenever there's a deviance in that pattern, it flags it off as an anomaly and immediately notifies you. All of this courtesy data science. Let's look at some languages to implement data science concepts. First in the list is R. R is the most widely used language for data science tasks. R provides more than 10,000 packages for different purposes such as data visualization, data manipulation, machine learning, statistical analysis, and so on. Next in line is Python. Well, Python and R are actually close in competition. Python also provides packages for deep learning such as Keras and TensorFlow, which help in creating deep neural networks quite easily. We can also use a good old Java to perform data science tasks. The biggest reason why people use Java is speed and scalability with big data. So it's finally time to implement all of the data science concepts with R. So let's go ahead and do that. And we'll be working with the Diamonds dataset to implement the data science concepts. So let's head to RStudio. So this is RStudio, guys. This is how RStudio looks like. So we'll start off by data manipulation. And since you would want to work with the Diamonds dataset, we would need to load the ggplot2 package. So to load a package in R, all we have to use is the library function. So I'll say library of ggplot2 to load the package. And the package has been loaded. Now, to do a bit of data manipulation, we would also require the deployer package. So I'll say library of deployer to load the deployer package as well. So we have successfully loaded the ggplot2 and deployer packages. Now let's have a look at the diamonds dataset. So view of diamonds. Alright, this is our dataset. Let's understand this dataset first. So we see that this is a data set which comprises of 54,000 diamonds, where price tells us the price of the diamond in US dollars, carat is the weight of the diamond, cut is the quality of the cut, color is the diamond color, clarity is a measurement of how clear the diamond is, X, Y, and Z being the length, width, and depth of the diamond in millimeters. Right. So now it's finally time to manipulate this data and get some insights from it. Now, from this data set, I would want to filter out only those diamonds where the cut is ideal. So over here, we saw that the cut or the quality of the cut can be fair, good, very good, premium, or ideal. Now I would want only those diamonds which have the ideal cut. So this is how I can do it. Now I'm using the filter function from the deployer package. So what I'm doing over here is, from the diamonds data set, I am filtering out all those diamonds where the cut is ideal, and I'm storing it in the object and naming it as ideal cut. Now let me have a look at this. So I'll say view of ideal cut. Right, so there are 21,551 diamonds which have the ideal cut. Right, now out of all of these diamonds, I would want to select those diamonds whose price is greater than 15,000 US dollars. So from this entire data set, I'd want to filter out those diamonds whose price is greater than 15,000, and I'm storing it in high price object. Now let me have a look at this. So I'll say view of high price, and this is the new data set where I see that there are 531 diamonds whose price is greater than 15,000 US dollars. Now similarly, I would also want to select those diamonds whose price is in between 10,000 to 15,000 and less than 10,000. So I'll do the same process then. So from the ideal cut dataset, I am filtering out those diamonds whose price is greater than 10,000 and less than 15,000, and I'm storing the result in medium price object. Now let me have a look at this. So I'll say view of medium price. Right. So this is the list of all those diamonds whose price is in the range of 10,000 to 15,000. Now similarly, I will select those diamonds whose price is less than 10,000 US dollars. View of low price. So there are 19,781 diamonds which have price less than 10,000 US dollars. So this was a bit of data manipulation where first we filtered out all those diamonds whose cut was ideal, and then we segregated them on the basis of their price. Now, what if I wanted to only select some specific columns from this entire data set? Now, I would want just these three columns from this data set. So what do? I use the select function from the deployer package. So here what I'm doing is, from the diamonds data set, I am selecting only the X, Y, and Z columns, and I'm storing it in diamond dimensions. So view of diamond dimensions, and I see that from the entire diamonds data set, I am selecting only the X, Y, and Z columns. Right. Now what I'll do is, from the newly created data set, I'll filter out those entries where the length is greater than 5 and the width is greater than 50. So what I see is there is just one entry, or there is just one diamond whose length is greater than 8 and whose width is greater than 58. Right. Now time to head on to the next data manipulation technique. Now what we're doing is we are filtering out the diamonds on the basis of their color. So over here we see that if the color is represented as D, then it is the best. So from the diamonds dataset, I am filtering out all those diamonds whose color is equivalent to D, and I'll store it in diamond best color. Let me have a glance at this. So I'll say view of diamond best color. Right, so there are 6,775 diamonds which have the best diamond color. Now out of these diamonds, now I want those diamonds whose clarity is IF, that is, who have the best clarity. So from the diamond best color dataset, I'll filter out those diamonds whose clarity is equal to IF, and I'll store it in diamond best clarity. Now let me have a glance at this. So I'll say view of diamond best clarity, and this is the new data set where the color is the best and also the clarity is the best. Now out of this new data set, I would want to find the average price of the diamond. So I'll use a summarize function. So now what I'm doing is from this new data set, I am finding out the mean of the price. So the mean price of the diamonds from this newly created data set is 8,307. So this was data manipulation. Now it's time to head on to our next task where we'll do a bit of visualization with the help of the ggplot2 package. At the start of the practical, we had already loaded the ggplot2 package, and hence we do not need to load it again. So over here what I'm doing is a bit of univariate distribution with the help of a bar plot. So ggplot is the function where I'm giving the data set over here. The data set is diamonds, and I would want to plot a bar plot with respect to the cut of the diamonds. This is the bar plot with respect to cut. So this function basically takes two arguments over here. First is the data set, next is the aesthetics onto which we are going to map the columns of the diamond data set. And in the plotting function, we are directly going to give the color, which is light salmon 3. Now what if I wanted to give separate colors to each bar? How would I do that? Now that is actually quite simple. So what we'll do is, instead of assigning the color directly, I'll assign the variable column cut to this fill attribute inside the aesthetic attribute. So now this gives me a different color for each bar of this graph. Now what basically we can conclude from this graph is that most of the diamonds are of the ideal cut and the least amount of diamonds have the fair cut. Now we'll do a bit of bivariate analysis with the help of scatter plot. So again, we are taking the diamonds data set and we are mapping the price column onto the y-axis, and we are mapping the caret column onto the x-axis. And since we want to scatter plot, we will use the geom point function in addition to ggplot. So this is the scatter plot. So we see that as the caret size increases, the price of the diamond also increases. Now let me make this graph more aesthetically pleasing. So what I'll do is I'll also add a color to this plot, and to add a color I'll just use the call attribute inside the geom point function and assign the color pale green 4 to it. So we have a result over here. We have successfully added the color to this plot. Now let's do another bivariate distribution where we'll try to find out the distribution of price with respect to the length of the diamond. So over here, the dataset uses diamonds, and we are mapping the price column onto the y-axis, and we are mapping the length of the diamond onto the x-axis. Again, the geometry used is geom point because we want a scatter plot. Now we are assigning the color medium orchid 4 to it. This is a similar plot to the previous one. So again, what we can conclude is, as the length of the diamond increases, the price of the diamond would also increase. So we did a bit of data manipulation, and following which we also did data visualization. So now it's time to come to the machine learning part, where we'll implement the linear regression algorithm. Now basically the linear regression algorithm helps us to find out the correlation between two entities. That is, if one variable changes, how does it affect the another variable? This is the basic premise behind linear regression. So let's go ahead and implement the linear regression algorithm. Now what we actually want to find out is, how would the other variables of this diamond's data set affect the price of the diamond, right? So I want to find out how would the carat, cut, color and other columns affect the price of the diamond. Now to do this, our first task would be to split the entire data into training and testing sets. So we can do that with the help of the sample.split function, which is a part of the CA tools package. I'll load the CA tools package first. So I'll just say library of CA tools, and this loads up the package. Now using the sample.split function, I will split the entire data set into 65-35 ratio. So I am taking this column and I'm giving it as the first parameter in this function, and the split ratio is 65. That is 65% variables or 65% observations would have the true label, and the rest of the 35% observations would have the false label. And I'll store the result in my split object. After doing that, I will select those 65% observations from the entire diamonds data set where the split tag is true, and I'll store them in the training data. Similarly, I'll select the rest of the 35% observations where the split tag is false, and I'll store them in test data. So we have two data sets over here, training data and testing data. Training data comprises of 65% observations, testing data comprises of the rest of the 35% observations. Now let me actually have a look at the number of rows of training data and testing data. So I'll just say n row of trained data. We see that there are 36,191 rows. Similarly, let me print this as well. So test data comprises of 17,749 rows. Now, after splitting the data set into training and testing data, we would need to build the linear regression model on top of the training data. So this is how we build the linear regression algorithm. So we will select the price column because that is what we would want to predict. So over here, price is the dependent variable, and all other columns except the price column are the independent columns. That is, whatever variable is given on the left side of the tilde symbol is a dependent variable, and the set of variables given on the right side of the tilde symbol would be the independent variables. Now after doing this, we would also need to give the data set, so which is the trained data. That is, we are implementing this formula on top of the training data, and we will store the result in model 1. So we have successfully built the linear regression model. After building the model, we would also need to predict the values on top of the test data. So this was the model which we had built, and we'll give the model as the first parameter. After that, we will predict this on the test data, that is, which comprise of the 35% of the observations, and we'll store it in result 1. Now what I'll do is, I'll combine the actual values with the predicted values. So from the test data dollar price, so we had the test data with us, and from that data set we took the price column, which was the original price values, and with the help of the linear regression model we had predicted some values. So these are the original values and these are the predicted values, and we'll store them in final data 1. So let's have a look at this final data 1 now. Now this data set comprises of the actual values of the price and also the predicted values of the price. Now our task is to find the error in prediction. So the error in prediction can be found out by subtracting the actual values from the subtracted values. Now to do that, let me actually convert this into a data frame first. So I'll just use as.dataframe function and convert this matrix into a data frame. Right. So as I had said, we'll take the actual values and subtract these actual values from the predicted values and store it in error object. Now we'll also bind this error object back to the final data set. View of final data 1. So these are the actual values, these are the predicted values, and this is the error in prediction. Now what if I wanted to find out the aggregate error in prediction? So we have something known as root mean square error for that. So root mean square error, as the name sounds, we would have to first of all find out the error, which is nothing but the actual values minus the predicted values. Then we'll find out the square of the error, then we'll take the mean, then we'll take the square root and store it in some object. So I've named the object to be RMSE1. Right. So the error in prediction is 1035. Now it needs to be noted that the lower the value of the model, the better the model. So what I'm going to do is I'm going to build another model and compare its accuracy with the first model. So I'll do the same thing. So in this, what I'm doing is, instead of taking all of the columns as independent variables, I'll just take the length, width, and the breadth of the column as the independent variables. And I'll store this in model 2. Now I'll repeat the entire same process. That is, I'm predicting the values. And after predicting the values, let me actually check the error in prediction, which is RMSE2. Right, now let me compare RMSE1 and RMSE2. So RMSE1 is 1035 and RMSE2 is 1716. Now this tells me that the first model is quite better than the second model. This was linear regression with R. So this actually brings us to the end of the video. So we started off by understanding what is data science, then we looked at some use cases of data science, following which we looked at different languages which could be used to implement data science concepts, and finally we implemented the data science concepts with R. So thank you for watching our video. And if you're interested in doing an end-to-end certification course, then you can check out our data science training course, where we provide training on topics such as statistics, predictive modeling, sentiment analysis, and time series modeling.
Thank you for watching our video. Do like and share it. If you have any questions, comment below and we'll respond to them as soon as possible. Also, do subscribe to Intellipaat channel so that you can keep yourself updated on the latest technologies. You can also go through other related videos in our playlist. And for more information, visit our website. Keep learning, keep improving.